Algebra 2, we are starting Unit 4, and the first section of Unit 4 is solving linear systems. If this looks familiar, it should, because this is the same topic that you guys learned in Algebra 1, solving systems. And all that means is when you guys have two, so linear, meaning lines, when you guys have more than one line. So a system meaning there are many parts to this whole situation. So I've got more than one line. I'm looking for where they actually hit each other. So where do they share a common point? That's what I mean by solving. So we're going to do this graphing and algebraically. And in order to do that, we want to make sure that we have some kind of real-life application. Why in the world are we doing this to begin with? So we've got a word problem. You guys are welcome to copy it or just put down the key points from the word problem. So you have 28 members in Jeb Stuart High School Ski Club, if we had a ski club. Every member went on a one-day ski trip. Members can rent skis for $12 per day or snowboards for $16 per day. The club paid a total of $376 for rental equipment. The members bought popcorn while they were at the resort for $4.50 each. Can we figure out how many members rented skis and how many rented snowboards? If you guys are looking at this word problem, I'm going to underline some of the key parts that stand out to me. I have 28 members. That's a number of total members that are part of the ski club. I also know that they rented skis for $12 per day. They also rented snowboards for $16 per day. We have a total amount of $376 that was paid for renting. And then we have another price down here. We have this $4.50 each for popcorn. First, I want to define the two variables that I'm working with here. If I want to know how many members rented skis and how many rented snowboards, I know that I have a total cost, and I also know I have members, a number of members that I'm talking about. So we are going to say, those are our two ideas that we're working with. But what we really want to know is how many of those members rented skis and how many rented snowboards. So what we're going to say is we're going to use X for skis and we're going to use Y for snowboarders. Okay? Write a system of two equations using the variables with the information that was provided. So moving on to step 2, I want to talk about my cost. Okay? And I also want to talk about my members. I know that if I look back, I'm actually going to start with members. I know if I look back up at the equation, at the word problem, I have 28 members total, and you have a choice if you're on the ski team to either be a snowboarder or a skier. So I'm going to say that if I took my skiers, which is X, and I added them to my snowboarders, I would have a total of 28 members altogether. I could have one skier and I could have 27 snowboarders. Right now I don't know. All I know is that when I add the two together, I have a total of 28 members that are possibly snowboarders or skiers. So now I'm going to look back at the cost. I've already dealt with this right up there. I'm going to check that off. I'm talking about the cost of snowboarding and skiing. This whole $4.50 for popcorn thing is extra information that I do not need. So I'm actually going to cross this out because I don't want to look at that extra information that I really don't need as part of my word problem, okay? At no place in this question does it ask me to talk about popcorn. So I'm going to take that out. The club paid total of $376 for rental equipment. Again, that doesn't include popcorn either. So I have a total of 376, and I'm going to put this over on the same side that I had my total number of members. So $376 total, and that was paid for the ski equipment and for the snowboard equipment. So for every skier, which is my X, I paid a $12 charge to rent. So for every X, I paid $12. On top of that, I paid $16 for every snowboarder. So that means if I had one snowboarder, I would have only paid $16 for them. But if I had two skiers, I would have paid $24, right? So I'm multiplying my X times the price per X. So I have two equations now. That's what step 2 asked me to do. Write a system of equations using your variables and the information provided. Now that I have these two, I'm going to go ahead and take a look at what I can actually do with them. So step 3 is solve the system. So what are the 3 methods used to solve a system of equations? Well, the 3 methods that you guys learned in Algebra 1 was to graph. So graphing was method 1. Substitution was where you isolated one of the variables and then replaced it in the second equation. And then the last one was elimination. Elimination is when we eliminated the x or the y. We got rid of one of the variables that we were working with so that we could just focus on one variable at a time. And we're going to walk through all 3 of those right now. With our ski example, though, we're going to solve by graphing. So we're going to take a look. I'm going to copy down my 2 equations. So I had x plus y equals 28, and then I had 12x plus 16y equals 376. Let's go ahead and put that down. So I'm going to say the ski problem said that x plus y is equal to 28, okay? And then I also had 12x plus 16y was equal to 376, I believe. I'm just going to go back to check. Yep, 376. Okay. If I'm going to solve by graphing, remember how I need to set up my equations in order to graph. If I want to graph, I need to actually isolate my y. So if I'm going to solve by graphing, I'll use red to solve by graphing. I need to isolate my y. So if I have x plus y is equal to 28, I'm going to subtract my x, so y equals 28 minus x. That's one equation. The second one, I'm going to have to, let's see, do a little more work. Let's subtract 12x. So now I have 16y is equal to 376 minus 12x. And then I'm going to divide by 16. So y is equal to 23.5 minus 0.75x. So remember, I have to divide the 16 into both terms in the numerator, the 376 and the 12x. Okay? So now I have 2 equations that are written in y equals form. And remember the number that's by itself. So in this case, the 23.5, and in this case, the 28. Those numbers that are by themselves are my y-intercept. So if they're my y-intercept, I need to make sure that if I draw my y-axis, I have it large enough for me to actually see where the 28 and 23.5, where those 2 y-intercepts actually are. So I'm going to take a second to mark my graph because I was just given a blank graph. So if I'd like to make sure I include up to 28, let's count by maybe 10, 12, 14, 16, 18, 20, 22, 24. That won't do it. Let's count by 5s. I know it'd be a little bit off. Okay? So that would be 5, 10, 15, and 20. Go all the way up. Okay? And I think we're okay to actually graph. Let's do, we can do 5 again this way. Oh, it's funny to do that. 5, 10, 15, 20. Okay, so let's see if that's enough. So right now I'm going to start at 28, which is approximately here. I'm going to use my red. So 28, about there. And it's negative x, so negative 1 means I'm coming down 1 and over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay? And then for 23.5, that would mean I'm starting about here. And I'm going down 0.75 and then over 1. So 0.75 is not quite an entire box and then over 1. Not quite an entire box and then over 1. Not quite an entire box, over 1. Not quite an entire box, over 1. Not quite an entire box, over 1. So if I wind up graphing these two, I can tell that I'm going to have a point of intersection somewhere there in the middle. If I'm graphing this on my calculator, I can find those points exactly by doing an intersection. So go ahead and grab your calculator, and I'll show you guys what buttons to push to see if we can find the exact intersection. Oops. Once you guys have your calculator, go ahead and make sure that you've gone to y equals up in the left-hand corner, and go ahead and enter your two separate equations. So I have 28 minus x and 23.5 minus 0.75x, all right? And you can always go back to your notes and make sure that you've written those in correctly. We got them, okay? So now I'm going to go to graph, and the problem is our y-intercept is too large. It goes above this 10, so I can't see it. So remember, I can either change my window or I can go to zoom out, which is number 3, and then you have to push enter again. And now I can see where they actually intersect. And this is the same button that we used for our minimums and maximums and zeros. I'm going to push second, trace. And you guys see number 5 is intersect. That second trace has everything we need, okay? And it's going to ask you the same series of questions that it kind of did on when we were finding our max and mins, but this time we're not going from the left and the right side. We're basically trying to find when two curves or lines hit each other, when they intersect with each other. So here it says the first curve, and notice that my blinker, my little cursor, is on the top line, this one up here. I'm going to push enter to tell the calculator that I want that curve, and then it says, is this the second curve? And notice how it automatically bounced me down to the next curve. Yes, I want the next curve, so I'm going to push enter again. And then it says, do you want me to guess? I would like you to guess. Go ahead and push enter. And it says 18 and 10. It found the intersection for us. So this is telling us that 18 is x. X, remembers, are skiers. So we have 18 skiers and we have 10 snowboarders. So I'm going to go back to my notes. And that is exactly what I want to write down. I have 18 skiers and 10 snowboarders. Okay? So x is, let's try that again. X is 18 and y is 10. All right? So I actually have my solution. See if I can put that back. All right. So I actually have my solution, and it was pretty close to what I was graphing, and then what I found on my calculator as well. But then the algebraic way of doing this is by substitution. With substitution, I worked out the problem here below, and I'd like you guys to try it as well. This 28 minus x was coming from the very first equation because it was equal to y. The 23.5 minus 0.75x was from the second equation, and it was also equal to y. Since they were both equal to y, we can set them equal to each other, which allows you to just solve for x because your y's are eliminated, and you get 18, which is what you wanted. To find y, we could substitute back into either of the equations. Be ready to do elimination.